Now I want you to note there is a glitch in this method, but there is also a fix for the glitch. Yes, there's a glitch. I'm sorry, but there is a glitch. And so we will find a way to fix that glitch.
I sincerely hope so.
Okay, so here's the problem. Case 1, no function in the yp in the particular solution is a solution to the homogeneous equation. Well, that's good. That's just like the last one we did. Actually, the last couple examples were like that, and that's wonderful when that happens. Case 2, a function in the assumed yp is a solution for the homogeneous equation. That could be a problem.
Oh, that's hard.
Well, it makes things tricky. So the fix is this. If yp contains duplicates of terms in yc, then multiply that term by x to the n, where x to the n is the smallest power of x that eliminates the duplication. Reduction of order would work also, but it wouldn't be as simple as this. And we like to keep it simple.
Oh, I see.
Yes, we keep it simple. Okay, so here's an example where that occurs. Y double prime plus 2y prime equals 2x plus 5 minus e to the negative 2x. Well, the characteristic equation m squared plus 2m equals 0 has roots m equals negative 2 and m equals 0, so our solution, our complementary solution, c1 times e to the negative 2x from this root, and c2 times e to the 0, well, that's just c2. So the normal guess particular solution would be yp equals this ax plus b is for this part 2x plus 5, and then c times e to the negative 2x, but I don't know if you see a problem there. There's a real problem here. There's a dual duplication, because look, we've got a problem with this because that is a constant. It's part of our yc. Well, there's another constant right there. Part of our yp. That's not good. Here's another problem. Look, constant times e to the negative 2x. Look, constant times e to the negative 2x. Oh no. So we're going to have to do something about that, and what we're going to do, we're going to multiply this part of the equation by an extra value of x, and this part by an extra value of x, and now we'll try to determine the coefficients. If you tried to do it the other way, you would find all kinds of problems. I won't even go into it, but you might want to try it just to see the problems you'll run into. So let's see. If this is what we're going to try, the first derivative of it would be 2ax plus b minus 2cx e to the negative 2x plus c e to the negative 2x. That's first d second plus second d first, product rule on this part. And then simplifying, we get 2ax plus b plus c times 1 minus 2x times e to the negative 2x. So that means our y double prime. We're ready for y double prime. Derivative of b is 0, derivative of 2ax is just 2a, and then the derivative of this is going to have another negative 2 multiplied by it, so it's going to be c times 4x minus 2 instead of 1 minus 2x, e to the negative 2x. Then that was, by the way, first d second, then second d first is going to be minus 2c e to the negative 2c. So I hope you see where all that fits in. The negative 2 is the derivative of this part. That's where this negative 2 right here came from. Okay, so multiplying this all out, 2a 4cx e to the negative 2x, 4c e to the negative 2x, and then when we substitute back into the original equation, that's back into this one. Whew! Here it is. Here is the y double prime, and here is twice the y prime, and that's going to be equal to this. So let's look at the terms that are, we got 4ax here and we got 2x here, so that tells us, and that's the only term with an x in it, right? So that tells us that a equals a half. Now 2b plus 2a equals this 5. Do you see where the 2b plus 2a is? Here's the 2a, here's the 2b. And so that has to be equal to 5. So we already know A is a half, so that means B must be 2. So now let's look at the terms with e to the negative 2x in them, okay? Well, we got, let me see, 4c e to the negative 2x, and then plus 2 times negative 1 times e to the negative 2x to see it. So we actually wind up with 6 c times e to the negative 2x, and on the right hand side that's going to be negative 1 e to the negative 2x, so c equals negative 1/6. And the solution is, by the way, if you're wondering, like, what happened to the terms with the x times e to the negative 2x in them? Well, here 4c x e to the negative 2x, and this 2 times negative 2 e to the negative 2x, they just canceled out, so they disappeared. So our solution is y equals yc, the complementary solution, plus yp. So c1 e to the negative 2x plus c2 plus 1/2. Remember, a was a half, b was 2, c was 1/6. Ooh, that's not correct though. 1/6, remember, times x. I had to multiply it by an extra x in there. So I think that's the solution now. Yes. Good.
Will this unit always be this complicated?
Not always.